Greetings, welcome back to Randomtronic. My name is Chris and today we'll do some soldering, finally. Because what could be more fun than melting some solder and connecting a few parts together to make it work? The finest type of entertainment under the sun. What we've got here is a bag of parts and a circuit board and a schematic and an instruction manual. Very extensive but sufficient. So first let's have a look on the website. This came from ICStation. It's the item DIY kit, eyesight protection circuit reminder kit, electronic production DIY module, item ID 13030, and they're selling it for $3.68. This was sent to me by ICStation. Here are some pictures of the module circuit board. We have 4 transistors, 1 photoresistor, 4 normal resistors, an LED photodiode and an infrared diode, and a pin header connector and a buzzer. So really simple circuit, only a few connections on the board. Please make sure to check out the link in the description. I'll link directly to this item on the Banggood website. I will also post a discount code that you can use. Here is the circuit board measuring 40 by 34, I guess 34 millimeters. Here is the schematic. Well, here it is. So what this is supposed to do is measure the light level in the room that you're in, and if the light level is not appropriate, it should sound annoying buzzer, this little thing. Let's see if we can figure out the principle of operation. Here is the simple schematic. As you can see, the instruction is mostly in non-English. All you really need is the schematic, and yeah, the drawings are universal language. The circuit is supplied with 6 volts as the power supply. Firstly, on the left here we've got a 200 ohm resistor that goes through a diode. It's an LED diode. This one here emits infrared, and that's right next to photodiode or infrared photodiode, which is the black one here. The way those diodes work, if they receive any infrared light, it will start conducting in the reverse direction. The next item here is a Npn transistor, and for that transistor to switch on we need more than 0.7 volts at this point on the base of the transistor. This will not happen if this diode is not conducting, because the base is tied to ground with a 1.5K resistor. So this is effectively at ground, so the transistor is switched off. If this diode was to start conducting, the voltage at this point will slowly increase. When it reaches roughly about 0.7 of a volt, this transistor will start switching on. And what happens then, because the collector of this transistor is tied to 6 volts through a 47K resistor, when it starts conducting, point here, which initially when this transistor is switched off, this is at 6 volts, will start dropping its potential. Effectively, when this fully turns on, this point will be at 0.2 of a volt. For this purpose, we can call that this will be tied to ground. The next stage of the circuit is this Pnp transistor. Because this is a Pnp, it works kind of in reverse as the NPN. It will not switch on unless the base is tied to ground. In the initial state, when the diode is not conducting, when it's not receiving any infrared, this transistor is not switched on. This point is tied to 6 volts. That means that this transistor is not switched on. However, when this diode starts conducting, the voltage in here increases, switches on this transistor, which effectively lowers the potential at this point, which is tied to the base of the Pnp transistor, and it starts conducting. On emitter of this Pnp transistor, we've got the red LED diode that will turn on, and on collector we've got the buzzer connected from the collector to the ground. If this diode can see the light emitted from this diode will switch on and the buzzer will sound. Now on the other side of the circuit we've got pretty much the same arrangement. Npn transistor with base tied to ground through a 100 ohm resistor this time, and here we've got a photoresistor. This is a resistor that changes its value depending on how much light it receives. Those are quite common, and yeah, here is the one supplied. It's easily identifiable by this squiggly pattern. Usually that's how they look like. They come in bigger and smaller sizes. When this starts conducting, because the resistor is again connected to 6 volts to the power supply, potential at this point will start increasing, and it will go at the beginning from almost 0. It will start going above, and when it reaches about 0.7 volts, it switches on this transistor, which in turn switches on this transistor. This looks kind of like a Darlington. This arrangement here has got a very high gain. If you think about it, each transistor has got its own gain. Very small voltage on here will cause a very small current going through base emitter. If you multiply that by the transistor gain, that will be the current that goes through collector emitter junction of the transistor, but that is directly tied to the base of this transistor. So that small voltage that's already gained by the gain of this transistor will get multiplied yet again and essentially fully switch on this transistor, which is connected to the same points as the other PNP. So it will switch on the diode and it will sound the buzzer. I guess what happens here, I'm guessing that the infrared part of it will only switch on if it is too dark. If the light levels are low, it should switch on the buzzer and light up the LED. If it gets too bright, I think the infrared diode will stop conducting because it will just get swamped with the other light. The same sort of thing, if it's too bright, your remote control doesn't work. And then of course the photoresistor, if it's too bright, it will switch on. So this should stay quiet only at a point where the light level is optimal preset value of this, which they claim to be the right value for your eyesight. So here's the photoresistor, quite bright on the bench, and as you can see, well, including my body right now because I'm touching the probes, but it's about 700 ohms. But if I cover it with my finger, immediately goes to 7k ohms, so 7000 ohms. If I remove this, there you go. And it's quite sensitive, so I can just hover my finger above it, and yeah, that's the photoresistor. Those are non-polarized parts, so it doesn't matter which way you put it, it will conduct in both directions. I've just noticed my microphone was rubbing on the shirt, so yeah, sorry for the sound disturbance. Here is a quick tip on how to check if a transistor is working, or maybe the transistor is the faulty component in your circuit. So when you take your transistor out, and let's say the only thing you have is a multimeter, put it in the diode mode, or sometimes the resistance mode would work as well, but basically try to work out if you get a connection. For a NPN transistor, you should have the red lead of the multimeter on the base of the transistor, which in this case is the center one, and the black lead on either emitter or the collector. I'm not sure which one's which in this case, I haven't checked, but as you can see, you should be getting about 0.7 volts, and that's the PN junction forward voltage. Try it in any other combination and basically you should get nothing. There shouldn't be any connection, and if that's true, you can be sure that the transistor is fine. For the PNP, it's pretty much the same. All you do is swap the leads, so the black one should go on the base, which is the middle one again, touch to the remaining two, and you should get 0.7 over volts. Now if you were to swap them, there should be nothing. Sometimes when the transistor is busted due to an overload, it will, for example, it will be either a dead short between two pins, in which case you know this is your faulty component, so you have to get it replaced. So let's put some components in. This is the 100 ohm resistor, and that should be according to our schematic, which I'll put here so you can see. That should be the 100 ohm R3, which is here on the board. The remaining ones, to keep them in place, what I like to do is get the legs of the transistors at a slight angle outwards. Keeps them nicely in place for the soldering. You can see they won't fall out anymore. So let's get some solder. By the way, I've got those two fluxes in here. I got those off of eBay. Those are fluxes from Thermoplastic company. It's a Polish company that deals with all sorts of soldering chemicals for electronics. TK83 and RF800. I think I'm going to use the TK83. So I'm just going to dab it here and there. No clean fluxes, so it's fine to just leave them on. Okay, so here we go. I'm trying out this new soldering tip. I'm not sure if I entirely like that, but it does the job. It's a little bendy one. I also haven't got my little pan of ice, which would have made this a whole lot easier, but it's a small little circuit, so we should be just okay. And that's all the resistors done. Cut the leads off. We can move on to other components. So next thing I'll put in will be the transistors 8050 and 8550. 8050 is the NPN, so that's Q1 and Q4. Put it in just in line with the footprint and bend the leads a little bit and get it all soldered. Next, let's put the diodes in, and that's about even. Then the photoresistor, this can go in either way. I've bent the legs a little bit on it so it doesn't fall all the way in. It kind of keeps it off the board. LED, positive here, longer is positive. Solder one leg of each, make sure it's straight, and yeah, solder the other one. Two last things, the buzzer. This has to go the right way in, so you've got a plus sign on one end, and also the longer lead, plus the pin connector. Pin headers often come out, they don't want to stay, and there's nothing to bend, so it's good to pick up the board and hold it in place. Just be careful because they do get really hot. As long as you solder one of the legs, it will stay in place. Then you can properly solder the other one and touch up the first one if needed. Or you can bridge them like so, which is always not what you want to do. That should be complete. So let's power it up and see if it works. I have my power supply set to 5.8 volts. That should be enough. Because the connector is really small, this one here, and I've only got crocodile clips, what I'm going to do is put a piece of electrical tape on one jaw. They won't touch where they're not supposed to. Like this. 5.8 volts, and I've set the current limit to 250 milliamps. And immediately you can see, yeah, it's beeping, so presumably it's too bright. As you can see, if I make it really dark, it stops. I'm not sure the infrared bit is working at all. Found the problem, so when I was straightening up the diode, broke the track that leads to the pad for the diode, so scraped off a tiny bit of copper off the track and put a bigger blob of solder, hold it to make the proper connection. And let's try that one more time. Yeah, so now it works as intended. Optimal amount of light. If we get any closer, less light, it will buzz again, and this is too much. Well, my bench is really bright, so I'm not surprised that it's saying that this is too much light. But yeah, if I put it in the shadow, yeah, you can see, yeah, that's okay. And if I keep going closer and I put it in complete shadow, it comes on again. It starts coming again. Quite spooky this. That's a nice little simple circuit, and that was fun to make. Hope you enjoyed that. I'll make it stop buzzing because buzzing is annoying, but I hope you enjoyed the little build and the quick video. Thank you very much for joining me. Thank you very much for watching. Please do make sure to subscribe, and please share those videos on social media of your choice, wherever you like. That helps a lot. For this one, that's it. So take care.